Hey everybody, it's about time I put my face in, I guess, one of these videos. Don't know if my face is inside the camera. But anyways, so we're going to start our next lesson today, which is slope as a rate of change. But before I do that, I want to start doing birthday shoutouts for people who I've missed over the last couple weeks. So right now we only have one of them. And my only one I missed so far was Nahamir. So happy belated, but that was about a month ago. And we have one more person coming up in a couple days. Okay, so here to the lesson. All right, so slope is a rate of change. Rate of change. I just posted these, by the way. A change in one quantity relative to change in another quantity. Rate of change is the slope on the graph. Okay, same formula, but needs units. Okay, so to find a rate of change, you are finding the slope. So reminder, slope is rise over run. Okay, so to recap, the rise over run, so rise is going up or down. If you're counting upwards, it'll be a positive number. If you're counting down spaces, then it's going to be negative. If you're counting, then we have run, so that's left and right. So if you're going left, counting left, then if you're counting left and it's negative, then if you're counting right, it's positive. Okay, so rise affects your y values, so it's really your y values over your x values, or y is dependent variable, dependent over independent. Okay, so y or x. Okay, so we just have this one question to go through today, and that is it. 1 second. All right. Okay, so this one says calculate the rate of change / the slope of the following graph. Okay, so we have here something distance versus volume of gas. So this is, I would assume, we're driving a car. So the further your distance is, so 300. The further you drive, the less gas you have in your car, right? So the gas will go on as you drive. Just some points here. This is 145. This one is 410. Okay, so we're going to calculate the rate of change. Okay, so what we did yesterday in Monday's lesson is we counted the spaces and then go across. So we started with the most left point, so this one, and we have to get to this point. So we do our rise first, so up or down. So in this case, we're going down, but we don't have a full space here. Okay, so we're not going to count. Sorry, we can do half and then 1, 2, 3. So kind of 3.5 spaces. And this one is 1, 2, 3 spaces to the right. Okay, but you got to be very careful with this one. So the ones we did yesterday, let me get out my lesson from, sorry, I keep saying yesterday, I mean Monday. So this is Monday's lesson. So if you notice that our scale here is going up by ones. So every time we counted a spot, we just moved 1. Okay, so we have to be careful with this one because one spot is not worth one square is not worth 1 anymore. In this case, it's worth 10. And over here, it's worth hundreds. Okay, so we could do one way. I'm going to show you. So slope is rise over run. So we're going to do the rise and then the run. So if you think about it, each space is 10. So we go 5 here because it's half. 5, 15, 25, 35. So we went down 35 on our scale. So that's a negative 35 since we counted downwards. And then from here we go 100, 200, 300 because each one is worth 100. So we went 300 to the right, so positive 300. Okay, but this question is asking for rate of change. So rate of change works with real life questions. So we're not going to leave it as a fraction. We are going to divide it. So we have negative 35 divided by 300. And we get an answer of negative 0.12 rounded liters per kilometer. So liters per kilometer. Okay, so back here, we said it needs units. Okay, so your units we need for rate of change. So negative 35 liters, so we decreased 35 liters, and then we went 300 kilometers. Okay, so if you divide it, it means that you go 0.12, so you lose 1.2 liters per kilometer. Okay, so now I'm going to show you a generic or a general formula that you could do for any points on a graph if you want to calculate the slope or the rate of change. Okay, so say we didn't know this counting method. So what we could do, well, there's a formula, it's this. Okay, so up here, your rise is your y values. So we want to know what is the change in the y's. So we went from 45 down to 10. So in order to go from 45 down to 10, so 45 down to 10, okay, we decreased by 35, okay? So the general formula is, and how do we do that? We subtract it. We do y2 minus y1. So what this means is you're going to take your second y value and subtract your first y value. I'll show you in a minute. Then your run is left to right, which is your x values. So what we want to know is what is our change in our x values. So we started at 100 on the x and we went to 400. So it changed by 300. Okay, so to do that, you just do 400 minus 100, which is 300. Or your second x value, subtract your first x value. Okay, so this is how it works. So your first point, you're going to call this 100 x1, and your first y value, y1. Then we have our second point, so this is our x2, and our y2. So our first point has the first x and the first y, our second point has the second x and the second y. Now what we do is we just plug these values into the formula. Okay, so first is y2. So where's our y2? It's right over here. So it's 10. So I'm going to do 10, subtract. So 10 is our y, it's our second y value. Subtract your first one. So 10, subtract our first one, which is 45. So we do 10 minus 45. All over x2, which is 400, minus our first x, which is 100. So we get 10 minus 45 is negative 35. 400 minus 100 is 300. So just a reminder that these 35 is your y values. So this was liters. So liters, and the 300 was the kilometers. So now we divide it and we get negative 0.12 liters. Look, liters per kilometer. Liters per kilometer. Okay, and that is the full lesson for today. Just to show you, actually I'm going to rewind and show you one from, say, yesterday, show you how the formula works. Just going to take this one here. So if I do y2 minus y1 over x2 minus x1. So our second value, so our first value is 1 and 1. And our second one is 4 and 3. So x1, y1, x2, y2. So our y2 is 3. So 3. Subtract our y1, which is 1. over our x2, or second x, which is 4, subtract our first one, which is 1. 3 minus 1 is 2, 4 minus 1 is 3, and that is the same as the one we got yesterday. Okay, so this formula you can use every single time if you want to. It's faster to count spaces, but you could use this formula here. Okay. So homework now, page 268, number 1 to 8 and 14. Okay, so work on those questions, and that is the lesson for today. I will be touching up on the one more lesson on Thursday or Friday. Maybe I'll try to get it up for Thursday so that you guys can finish it for Friday, so you won't have anything over the weekend. I'll try to, but I'm not know if I will get there. And then I'll also send you guys an updated mark soon, so I'll post that in the announcements. Okay, I hope everyone's well, and I'll catch you later.